Hello students, this is Dr. Anita Raj, your chemistry mentor, welcoming you for a new session in chemistry, that is polymers. Okay, so today in this session I'm going to teach you the important terms involved in polymers. Okay, actually polymers are a giant molecules having very high molecular masses, and they have molecular masses as high as 50,000 or even more. So such type of molecules occur in nature and also can be synthesized in laboratory, right? Actually, there are two types of polymers, natural polymers and synthetic polymers. And these are some of the common examples of naturally occurring polymers like cotton, DNA, then wool, rubber, then a protein, cellulose, starch, resins, etc. And these are some common examples of naturally occurring polymers. And these polymers, they find a variety of applications in our routine life. Okay. And besides these natural polymers, we have some man-made polymers also. For example, see these hoses, raincoats, then PET bottles, then Teflon utensils, plastic covers, and these are the automobile parts. Okay, and these are made up of synthetic polymers. Okay, in fact, these polymers they find a wide range of usages starting from common household utensils, then automobiles, cloth, furniture, etc., to spacecraft and biomedical and surgical operations. Okay. I hope it won't be an exaggeration to say that the age in which we live today is the age of polymers, because we cannot think of smooth running of life without these polymers. Okay. So let us see about these polymers in detail. Okay. So what are polymers? Actually, polymer is a macromolecule formed by the repeated linkage of large number of small molecules called monomers. Okay. So actually this polymer is a Greek word where poly means many and mer means unit. Okay. So a polymer is a large molecule of very high molecular mass formed by the repeated combination of a very large number of one or more types of small molecules called monomers. Okay. As I told you earlier, this polymer is formed from the repeated linkage of this monomers. Okay. By the way, what is a monomer? Actually, this monomer is a building unit of a polymer. Okay. It is so the small molecules which combines to form polymers either by addition or condensation are called monomers. Okay. So this is a monomer. A monomer is a small molecule. This monomer, this combines repeatedly. Okay. See here, this monomer. This is a monomer. This combines repeatedly, many number of monomers, n number of monomers, they combine repeatedly to form a long chain called polymer. So a polymer is a long chain molecule made up of a repeated pattern of monomers. Can you understand? Now I shall give some examples for this monomer. For example, CH2 double bond CH2. See, this is ethylene. Okay, this is ethylene. Now when n number of ethylene molecules, when they combine, we get polyethylene. Okay. So what happens is this double bond breaks and we get two bonding sites here. So that is called as a repeating unit. Okay. So how it forms a repeating unit like this, CH2 single bond CH2. Okay. So now here also we'll have a bond. Now the n number of this repeating unit will combine together to form polyethylene. Okay. How it forms a CH2 single bond CH2 single bond. So we should write N here. So here in the reactant side, N should be written here. Okay, this is nothing but polyethylene. Okay, polyethylene. This is a polymer. Now another example. Let me give vinyl chloride CH2 double bond CHCl. This is vinyl chloride. Okay, vinyl chloride. This is a monomer. Okay, this is a monomer, and n number of vinyl chlorides they combine repeatedly to form polyvinyl chloride CH2 single bond CHCl. Okay, we can write Cl here also. Now here we will have a bond and repeated linkage will get should be represented as N at the bottom or at the suffix. Okay, so this is nothing but PVC or polyvinyl chloride. Okay? Now next let me give one more example, CF2 double bond CF2. This is tetrafluoroethylene. Okay, this is tetra. Tetra means 4. So 4 fluorine molecules are there. So tetrafluoroethylene. Okay, so this tetrafluoroethylene, now This is a monomer. Now n number of monomers they combine to form CF2 single bond CF2. Okay. Now we shall put n here. So the name of this one is a Teflon, but it is polytetrafluoroethylene. Okay, this is polytetrafluoroethylene. The other name for this polytetrafluoroethylene is a Teflon. Likewise, we are having so many examples for monomers. Understood? Now let us see what is a polymerization. Polymerization is the process of formation of a polymer from a monomer. Okay. So I have taken example ethene CH2 double bond CH2. So what happens during polymerization is this double bond it opens up. Okay. This double bond opens up and we will be getting two bonding sites, two new bonds. So each carbon can make a new bond. Okay. So two bonding sites are there. Now this is called as the repeating unit. Now this repeating unit it combines again and again. That is n number of this repeating unit combines to form a polymer. So CH2, 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 CH2. Then this is another monomer. CH2, CH2. This is another repeating unit. This is another repeating unit. CH2, 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 CH2. So new bond links repeating units together to form a chain. Okay. So the new bond is formed which links the repeating units together to form a chain. So this is a polymer and example is polyethylene or polyethylene. Next important term is functionality. So what do you mean by a functionality? Okay. The number of bonding sites present in a monomer is referred as its functionality. What is functionality? It is the number of bonding sites. Okay, number of bonding sites present in a monomer is referred as functionality. See, all type of organic molecules cannot act as a monomers. Okay, an organic molecule can act as a monomer only when it possesses at least two bonding sites. See here, this is ethylene molecule. This double bond breaks, and since the double bond is breaking, we are getting two new bonding sites. Okay, no substance can act as a monomer if it has only one bonding site. So a substance can act as a monomer only if it possesses two bonding sites. Only then a bond can be formed repeatedly. Can you understand? So now under functionality, we are having two types. First one is a bifunctionality. So what do you mean by a bifunctional monomer? So what do you mean by bifunctional monomer? When a monomer has two bonding sites, then that monomer is referred as bifunctional monomer. Can you understand? See, when a monomer, if it has two bonding sites, we call that monomer as bifunctional monomer. Okay. Ethylene glycol, that is a CH2OH, CH2OH. Okay. CH2OH, then CH2OH. This is ethylene glycol. Okay. And this is a bifunctional monomer. And this is because it has two OH groups which can easily combine with COOH groups to form a ester linkage. Okay. See, this is the pictorial representation of the polymer formed by this bifunctional monomer. Okay, this is a bifunctional monomer. Look at this bifunctional monomer. This is having two bonding sites. This is also having two bonding sites. Likewise, it is all the monomers are combined together. Here also all the monomers are combined together. Now let us see the significances of this bifunctional monomer. The first significance is it forms a linear straight chain polymer. So the bifunctional monomer it forms a linear straight chain polymer. Okay. So bifunctional monomer forms only linear or a straight chain polymer. This is because in the case of bifunctional monomer, the bonding groups they attach side by side to each other, resulting in the formation of a large linear molecule. Okay. And the next significance is, see, all the monomers are linked by means of covalent bond. Okay. So in the case of a linear molecule, the monomer units are linked by means of stronger covalent bond. Okay. They are linked by means of these bonds are strong covalent bonds. Okay. And the next significance is different chains are linked by means of van der Waals forces. Okay. See, whereas the different chains, this is one linear chain and this is another linear chain, and these two different linear chains are linked or held together by weak van der Waals forces. Okay, they are held together by weak van der Waals forces. Okay, so due to the presence of this weak van der Waals forces, there is no restriction on the movement of one chain over the other. So this is because there is the presence of weak van der Waals forces. this linear chain, it can move easily, and this linear chain also can move easily, though they are held up by weak van der Waals forces. Okay, can you understand? So the next significance of this bifunctional monomer is the chains can move freely. Okay, why the chains can move freely? Because the different chains are linked by means of a weak van der Waals forces. That is, it is a secondary bond. So the primary bond is the strong covalent bond which links the monomers. Okay, can you understand? Now, because of the presence of this weak van der Waals forces, these polymers they have a less strength. Okay, they have less strength. They possess a low heat resistance, and also they are very soft. Okay, so next significance of this bifunctional monomer is the polymers are very soft, they have a less strength, and they have low heat resistance. Can you understand? So these are the significances of a bifunctional monomer. Next we shall see what is a trifunctional monomer. Okay. When a monomer has three bonding sites, then the monomer is referred as trifunctional monomer. Can you understand? So this is a monomer. This is having one bonding site, another bonding site, another bonding site. So three bonding sites are there. Here in this monomer, 1, 2, 3. Okay. So three bonding sites are there. So if a monomer has three bonding sites or three reactive sites, we refer that monomer as a trifunctional monomer. If a monomer is having more than three bonding sites, then we call that as a polyfunctional monomer. Okay. Now let us see the significances of this trifunctional monomer. Okay. So the first significance is the polymers formed will be having a three-dimensional network. So look at this structure. Okay. In the case of trifunctional or the polyfunctional monomers, the polymers formed consist of a three-dimensional network. Okay. So in such type of polymers, the monomer units are connected together by means of covalent bond, strong covalent bond. See here, all the monomers are linked by means of strong covalent bond. Okay. So in the case of a trifunctional polymer, the monomers are linked by means of covalent bond. Whereas the different chains, see here, in the case of bifunctional monomer, different chains are linked by means of weak van der Waals forces. Whereas in the case of trifunctional monomer and polyfunctional monomers, the different chains are linked. Here also they are linked by means of strong covalent bond. Okay, so the different chains are linked by means of strong covalent bond. They are connected by means of strong covalent bond. So because of this, the movement is restricted. Okay, so in this type of polymer chains, the movement is a little restricted because of the strong covalent bond present. Okay, so the movement is completely restricted and are also held together by strong covalent bond. Can you understand? Since because the movement is completely restricted, there are certain other drawbacks. Okay, so here as I told you, the chains cannot move freely. Since because the chains cannot move freely, they are having some disadvantages. That is, they are very hard. But this you cannot tell that this is a disadvantage, because we can make use of these polymers in case of automobile spare parts and so many other things. Okay, so the polymers are hard. This type of polymers, they are very hard, they are tough and with high strength, and they have high heat resistance. Okay, so such type of polymers, they possess high strength, high heat resistance, and are quite hard and tough. Can you understand? So these are the significances of trifunctional monomers as well as the polyfunctional monomer. Okay. So next the important question is, what do you mean by degree of polymerization? Okay. What do you mean by degree of polymerization? It is nothing but it's the number of repeating units present in a polymer. What do you mean by repeating unit? It's nothing but number of monomers. Okay. So number of repeating units present in a polymer is referred as degree of polymerization. Say look at this polymer. So how many monomers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So degree of polymerization 9. So 9 repeating units. Here it is 10. Here it is 11. So when you take the average, it is 10. Okay. So what is degree of polymerization? It is the number of repeating units present in a polymer is referred as a degree of polymerization. Well, fine students, I hope you might have understood what I have taught today. Let me meet you with another important topic in my next session. Until then, it's Dr. Anita, Geochemistry Mentor signing off from you. Thanks for watching.